Okay, you should have watched lesson number 34 and attempt the tutorial questions. Okay, after the session, you can also go and download or attempt the extra questions. Okay, all right. Let's get going with another exciting speed today. Okay, just a quick recap. We have the speed ratio, speed formula triangle. Okay, whereby this is your divide and this will be multiply. Okay, so you have two of these. All right, now, okay, the other part that we learn in terms of speed ratios will be your common distance, and the second one is we learn common speed, a common time. There's no common speed. If you have common speed, means you cannot find anything because all moving at the same time at the same pace. All right. So with a common distance, so always remember there are three things. If you have a common distance, that means you can find the speed and the time ratio. Okay, and with common time, you can find the distance or the speed and the distance ratio. Okay, now, so for the speed, for common distance, the ratio between speed and time is indirect or it is reverse. Okay, if you want to remember it, this is direct. The ratio between speed and distance given a common time would be the same. All right. Okay. Turn your camera on, Marine. Are you able to turn on your camera? I think some of you, your device is not able to support background. I think I suggest you take that out. Okay. Otherwise, you'll be missing all the time. Okay. All right. Now let's look at question number 1. So in question 1, we have at 6:46 a.m., a sports car started traveling at an average speed of 64 kilometers per hour. So at 6, so this is the distance timeline. So that means at 6:46 a.m., a sports car started traveling at an average speed of 64 kilometers per hour. Now, oh, no worries. Then it's fine, Marie. No problem. Okay. Started traveling at 6:46 a.m. and at 8:46 a.m. a lorry started traveling from the same place. So lorry at 8:46 a.m. Okay. Now, in this instance, between 6:46 a.m. to 8:46 a.m., the time taken here is how long? What's the time taken here? How many hours? 2 hours. Okay, so that means the car which started at 6:46 a.m. at 8:46 a.m. in 2 hours time would have covered a certain distance. Now, because we know that the speed of the car is 64 kilometers per hour, that means in 2 hours, what is the distance covered by the car? In 2 hours. What's the distance covered by the car in 2 hours? You watch some videos while I'm talking, Brian. Okay, anyone? Thank you, Pranati. Okay, Pranati, try again. Marine, thank you. Okay, so 2 hours to find the distance will be equals to speed times time. So if the speed is 64 times 2 hours, this is 128 kilometers. That means in 2 hours, while the lorry started, the car has already traveled, yes, Hannah, the car has already traveled 128 kilometers. Okay, now, so the lorry started, and then what happened is as the car continues and the lorry continues at some point. Okay. Now, at some point, if the lorry took 4 hours to catch up, so at some point, they would have met or they would have catch up. Not the ketchup tomato, they would have catch up. Okay. Now, so find the speed of the lorry. So that means by the time they caught up, it is in 4 hours time. Now, can you see this? At this point where they met, what is common? Common. There are 2 ways to do this, okay? So at the time that they caught up, that means we're talking about the same distance, right? Okay. Now, we know that in 4 hours, the distance covered by the car would be 256 kilometers. Now, from here, if we know that the total distance here is given by 128 plus 56, that means in 4 hours, the lorry would have covered how much? Total distance covered by the lorry in 4 hours would be 128 plus 256 kilometers to give me 384. Now, thank you. Okay, now, so from here, will I be able to find the speed of the lorry given that the lorry took 4 hours to cover 384 kilometers? Yes, thank you, Brian. Good job, Hannah. Well done. I like the blah, blah, blah. Okay, so anyone, what is the distance besides Brian? Can you find what is the speed of the lorry given the distance and the time? Sharon, you want to try? How do you find how do you find the speed of lorry? Thank you. So distance divided by time to give me 96 kilometers per hour. Thank you. Okay, Pranati, well done. All right. Okay. Now, I'm going to move on to the second question. Okay, anyone still taking this down? Otherwise, I'm going to move on to the second question. Rita looks so cool. Actually, they have physical glasses that looks like that. Okay, let's look at question number 2. We have Sabrina, Jessica, they had a bicycle race. So the keyword here, race, means it is a common distance. So when you see keywords like this, what comes to mind? Things like common distance, okay? They must have the same start time. They must have the same start points. At the point where they start must be the same. Okay, so Sabrina cycles at a speed of 20 kilometers per hour, whereas Jessica cycles at a speed of 24 kilometers per hour. So because we have common distance, we know that we can find the speed and time ratio between Sabrina and Jessica, right? So we know that the speed of Sabrina is 20 and the speed of Jessica, okay, the speed of Jessica is 24. So to simplify this ratio, we have 5. Okay. 5:6. So the time taken will be 6:5. This is what we have. Okay, now, if Jessica let Sabrina start 36 minutes before her, wow, so kind. So this is the start time, the start point. So Jessica let Sabrina start 36 minutes before her, and then she starts. Okay, at this point, the time is the same. Okay, so then we let them continue. So at some point, they would have caught up, catch up, right? At some point, yeah, at some point, Sabrina would have caught up with Jessica. Now, the time taken that here and the time taken by Jessica must be the same. Okay, so we look at this time here. We know that for a common distance, okay, now for a common distance, Sabrina would have covered 36 units of time, whereas Jessica would be 5 units of time. So that means this must also be your 5 unit. That means this will be 1 unit of time. Yes, Jessica would have caught up with Sabrina. Yes, that's what I said. Or unless I said the other way. Okay, now with this, question says, how long would Jessica take to catch up with Sabrina? How long would Jessica take? Jessica took 5 hours. And since we know that 1 unit is equals to 36 minutes, that means 5 unit will be 5 times 36 minutes to give me 180 minutes. But because your answer is in hours, so this 180 minutes is equals to 3 hours. Okay. Well, you can choose to convert 36 minutes straight away. Okay, 36 over 60. 36 divided by 60 will be 3 over 5. Okay. So all you need to do is take 3 over 5. So if 1 unit is 3 over 5 of an hour, that means 5 unit will be 3 over 5 times 5 to give me 3 hours. So both will give you the same answer. Wow, so fast. Okay. All right. Questions? Anyone? No? Okay, now. Okay. Let's take a look at question number 3. Okay, question number 3. So Victor, I think you're having issues with your camera, and Brenda also. Renzo, is it? Will I call you Renzo? Sorry, yes, okay. How many questions are there today? The worksheet, did you manage to access the worksheet, Marine? So you know that there are actually 8 questions, I believe. Is it 8 questions? Yes? 7 questions. Okay. Thank you. All right. So let's look at question number 3. So D and E is 630 kilometers apart. Now, when it comes to speed question, it is always important that you draw the distance timeline, put in all the information so that it's easy for you to solve. So if I just look at the first part, I know that it is from city D to city E. The distance is 630 kilometers apart. Okay. Farron left D going towards E at 11 a.m. traveling at a speed of 70 kilometers per hour. Okay, so we have Farron who left at 11 a.m. traveling at 70 kilometers per hour. Okay, so this is what is the information here. So all this information are already in my distance timeline. So, and then we have this other information about Paul, who left D later and caught up with him at 3 p.m. So we know Paul left later and Paul caught up at some point, which is at 3 p.m. Okay, now at some point, wait, hang on. So when Farron moved, at some point,